So we are going to start with a new service, SQL database service. Mind you, this is not SQL server, but something similar to SQL server. So we are also going to understand, of course, what are the differences between SQL server and SQL database service. People earlier used to call it as SQL Azure or Azure SQL, but now it is referred as SQL database. So we are going to begin with introduction. We will compare on-premise SQL Server with SQL database. We are going to compare in general SQL Server with SQL database. What are the SQL tools which we have for migrating the data from local database to Azure? We are going to do planning and deployment. What is the concept of elastic pool? Pretty important. We will see how we can do monitoring, configuration, how we should ensure that the continuity of the business is maintained even in case of failure at one place, how to do import and export of database, how we can take up the backup, how we can take the backup and recovery, what is the concept of active geo replication and long-term backup retention. So pretty lengthy subject, and I believe more relevant to actually developers, because they are the one who are going to create a database and also program a database. That means program an application which is going to store data and retrieve data. But of course, infrastructure guys also have lot of role to play in maintenance, monitoring and stuff like that. So what is SQL database? SQL database is a cloud-based relational database service. Very important is relational. It is as good as SQL Server relational service. Yes, we have got this also as a relational database service. That means there are certain databases which are not relational, like document DB and stuff, which we are going to learn later. No SQL database we call them. So it's a relational database service that is built on SQL Server technology. It supports TSQLs, table, indexes, views, primary key, stored procedure, trigger, roles, functions. In general, I would say almost everything which a developer would need in routine programming in the form of SQL database is also there. I mean, in the form of SQL server is also there in SQL database. So a developer generally creates tables, views, stored procedures. He creates indexes, constraints, all these things for primary key, foreign key. These are all part of SQL database also. SQL database delivers predictable performance, scalability with no downtime. That is most important thing. You can always scale your application. That means you can increase the pricing tier, you can allow multiple customers, and you don't have to do anything at the hardware level or at the software level. You have to only do configuration and it becomes scalable with no downtime. Your business continuity is maintained. You can see how we can probably replicate the data so that even if one data center goes down, from other places we can still have the data available. And very important, the security, the data protection is also taken care. In short, it is literally zero, near zero administration. So the role of database administrator will drastically reduce, or rather almost it becomes zero, I would say, when we are making use of SQL database, because we don't have to do the database backup, we don't have to do the database recovery, we don't have to do the hardware maintenance, we don't have to do the SQL server database maintenance. All these things which generally an administrator is supposed to do are now done by Azure platform for us. So as a developer, one would be happy to focus upon the developing aspect, developing and accelerating the application development. That means you will become more productive. That is the advantage, I can say. And because it's based on SQL Server engine, the developers would not have to learn anything new. If you are a .NET programmer, happily you can continue using ADO.NET. If you are a Java programmer, you can use JDBC. Like that, OLEDB provider, all the existing APIs which actually work with SQL Server are going to work even with SQL database without any problem. Available in three pricing tiers: basic, standard, and premium. Obviously, basic is ideal for development or extremely low database load. And what we generally use in production is standard. And when we need high performance, extremely high performance in memory database kind of stuff, if you want, then you'll have to go for the pricing tier, premium pricing tier. And very importantly, you can always switch from basic to standard, standard to premium, or reverse without any downtime. You can change from one pricing tier, service tier, to another pricing tier, and you don't have to do, you don't have to shut down your database and restart. So what are the main benefits? High availability. There are 3 replicas created. So that means even if one goes down, automatically Azure is going to serve it from the other 2. That's why it is high availability. It is on demand. Unlike SQL Server, which might take probably hours to install, here you might probably need just few mouse clicks and your SQL Server, or I would say SQL database service, will be up and running. So on demand, you can create databases on the fly as per your requirement. There is no complicated procedure for doing that. And as I said earlier, there is almost zero administration. That means reduced management overhead. We don't do a lot of maintenance here. We let Azure to take care of most of the stuff. So top features of SQL database: tables, views, all those things, constraints, transactions, temp tables, basic functions, constants, cursors, all these things which are routine are part of SQL database. Temporary tables, all these things are actually ones which we use in our projects commonly. We can write stored procedures. We can write triggers using transact SQLs. We can also use statements for create and drop database, and so on. Now this is important list. The following features of SQL Server are not supported in SQL database. Very important, are not supported. Windows authentication. No, you'll have to compulsory use SQL authentication only. There are few transact SQL commands which are not supported. For example, you're not supposed to use database kind of stuff. User defined data types we do not have here. We do not access to system tables. CLR support not there. That means provision of writing stored procedure in C# or VB.NET. No, you don't have that. Database file replacement facility, database mirroring, distributed queries, distributed transaction. No, we don't have. We have to perform all our transactions on a single database only. File group management, full text search. This is something which generally in large applications we would need. But yes, in SQL database we do not have. Global temporary tables, which we want to use it for temporary data. Support for SSAS, SSRS. We don't have those replication. Backup and restore feature of SQL Server is not there because it has got something of its own. So because it is part of Azure, most of these features are actually not required. Like backup and restore, not required. Mirroring is built in. We have 3 copies of a database automatically created, and so on. But most of the routine features, yes, are part of it. So note that SQL database supports horizontal scaling, and SQL database requires clustered indexes. These are part of the SQL database requirement. less features than the boxed version. The boxed version is on-premise version. So SQL database is actually platform as a service. Now, if so many features are not supported, and in worst case scenario, if suppose I want these things in my project, then so in that kind of case, what to do? That is when what we do is we create a Azure virtual machine, and on that Azure virtual machine we are going to provision an SQL server database. That means actually we can create an SQL server workload virtual machine, a virtual machine with SQL server workload, and in few minutes it will get provisioned for us. So now we have actually three options. One is the SQL server on premise. Second is SQL server in Azure, that is Azure virtual machine, and SQL database. Mind you, SQL server on premise and SQL server on Azure virtual machine, there is not much difference. The licensing issue, but otherwise there is no difference in terms of the functionality. Both are same. So here I am comparing SQL database with SQL server on on the virtual machine. Yes, SQL database has comparatively less number of features, but it is optimized for cost. It's complete set of features, but pretty expensive. There is DTU, something called as DTU. We'll talk about it later, but right now for you, DTU is the measure of performance. How much faster the queries should execute. That is measured by DTU in case of SQL database. So performance is measured with a maximum of 1750 DTU in premium tier. But remember, for a basic load, minimum basic load, even 10 DTU is good enough for execution. If you do not have lot of load, lot of visitors, lot of complicated queries, if you don't have, even 10 DTU or maybe 50 DTU is good enough. But up to 1750 DTU is what SQL database supports in the premium tier. Of course, here it depends on what is the configuration of virtual machine you have chosen, how much of RAM you have chosen, have you chosen HDD or SDD, and so on. So those things, those factors will also decide the performance of SQL server in Azure virtual machine. Here there is a limitation. You can have maximum 1 TB. Actually speaking, 1 TB is pretty large, but there are certain very special cases where we want to have huge amount of database. So we can go up to 64 TB of data in case of Azure Virtual Machine Godzilla series, G series. But remember, in Azure, we try to avoid storing everything in SQL Server. We want to probably store only relational data in database. Large files, large documents, we would store in a storage account, maybe as a blob or maybe as the files, but there is a separate provision for storing, and that is comparatively very cheap. Storage account pricing is much cheaper when compared to SQL database. So large document, when we are not storing in database, the requirement of the database size will drastically go down. Documents are not going to be saved in database in Azure. Sizing by average usage, whereas here you have to take the peak load into consideration and then you have to create the size. Here you take the average usage and based on that you take care of the pricing tier. Built in by the platform, 99% SLA is provided here, but here you have to always take care of it manually. It doesn't do it for you. You have to manually do the configuration of always on AG that covers just virtual machines in the availability set. You do have the concept of availability set, but that only covers the virtual machine, that doesn't cover the database. You have to take care of that rest. Necessary fault handling, it's all built in. recommended fault handling and retry. You have to manage here manually. No co-location with application. So your application will be on one machine and your database guarantee will be on a different machine. Your application and the database do not coexist. But here you have a choice. You can actually bring it as a part of one single virtual machine, your application as well as the database. Or maybe at least on one virtual machine, you might have the database. On the other virtual machine within the same VNet, you might go for the database, you might go for the application. That means within the same network, we might have the application and the database together. Internal exposed endpoints. Here, internal private endpoints are possible. That means we can restrict it to only VNet. But here, if suppose you allow the firewall, people from internet can happily use it. Absolutely zero control over updates. Microsoft is going to take care of it. Azure platform is going to take care of it. Full control over database upgrade. You have the choice when you want to do an upgrade. Cost very low and pretty high. This is the way the cost of the application is decided. Highly minimized administration cost. Because why it is low? Because the administration cost is almost zero here. Software development cost is zero here. That means you're only paying for the SQL database service cost. Whereas here, yes, there is a administration cost, there is a development cost, management cost, SQL Server and Windows licensing cost. Windows also you have to take license. If you are hosting on a Windows server, Windows licensing cost also you have to take. And of course, you'll have to take care of the Azure cost, storage cost. So pretty expensive when compared to the SQL database in Azure, SQL service in Azure. This is comparatively costly. No full DBA. Yes, full stopped DBA. Easy to manage. Complex management. Tools and frameworks are available. No easy scale out option here. Here just few clicks you can scale out. No setup customization. You have absolutely no control on installation. It's all ready made there. You're only provisioning your database in something which is already there. But here, because we take care of the complete installation, the SQL and the SQL server is on the proper full-fledged operating system to which also you have access to. Yes, you can do that customization configuration with OS. Only SQL server authentication. In case needed, you can do Azure Active Directory authentication add-on. You can do a service level restriction, role based access control we call it. But for that, Azure Active Directory users are supposed to be given permission. But here you have got SQL Server authentication and integrated Windows authentication is also supported. Security, no, you do not have a fixed IP and only on port number 1433 it is supported. On other port numbers we don't have the choice. Whereas we have the complete control here. And it goes on in short, probably you can read the rest. What I would say is, in short, here you have more control, here there is less control, but at the same time reduced cost, reduced maintenance, and most of the stuff are taken care by the Azure itself. So let's now dig into the practical aspect. We have to now create an SQL database. But for creating an SQL database, this is SQL database actually. Before that, we should create a SQL server. Now, SQL server does not mean proper SQL server here. Remember that. SQL server here basically means that we are creating a logical container of our databases. That's it. It's just a logical container for common configuration to multiple databases which we might host. For example, I have already created something called as Deckensoft DB here. and under decans of DB, I may have around 6 to 7 databases, you see. So for this 6 to 7 databases, I have some common configuration. So likewise, I would like to now create a new database server for demo. I'll call it as DSS SQL demo server. DSS SQL demo server. That's the name I'm giving. We have to then give here administrator username and password. Using this administrator username and password only, we are going to create databases in this SQL server, the logical server. You can see here also. It's just a logical server. Give the password. We'll create a new resource group. Location, I'll leave it as Central US. So it is now going to do the validation. When everything is fine, it will create the database. And it's going to take a while for the database to get created. I mean the server, SQL server, the logical server to get created. You can see the progress here. Once that is created, we will have to then go to the SQL databases. Add. I'll call it as SQL database. I mean demo DB. We'll use the existing resource group. Server, once it is completed, I'll click here. There is some concept of elastic pool. Right now we are not interested in elastic pool. We'll come back to that topic and discuss later, but right now we are not interested in it. Oh, no servers found. I'll have to start again. Automatically server is selected. Pricing tier. See, as I said, there are basic, standard, premium, and they have added one more actually recently. Premium RS. Premium RS has little difference, and this is in preview also. It's for IO and compute intensive workloads with reduced availability and durability. This has got very high availability and durability, but with little reduced. This is much cheaper. You see, it is like this: 30,000 per month to 7,500 per month approximately. So DTUs is still 125 to 4,000, whereas here it is 125 to 1,000 only. So actually DTU now is, earlier it was 1750, but now we have support up to 4,000 DTU in premium. So that means they have doubled, literally doubled it. And basic is good enough for testing purpose when a single user is working, but of course your queries will be executing slow here. Standard with 10 is the bare minimum which we would probably have at the time of production. So DTU, more about it we are going to discuss later, but right now DTU is what we are supposed to provide at the time of creating the database, and at the same time we have to specify the storage. But what is important is storage is not going to, you can have up to 250 GB, the cost will not be varying. It's your choice. You can restrict it and say you want 500 MB, or you can go up to 250 GB, but the cost will remain zero. That means the major charge is only for the DTU here. In all places you see, this is not deciding the factor. And you can start with as simple as 330 rupees per month. That is per month. 329.89 is the average cost per month. You can start with something like that. Or maybe I would say if you're going for 10 DTUs, something like 2000 or 1000 actually, if you have 10 DTUs, just 1000 INR. So click on apply, click on create, and now it's going to take some time to create the database. Obviously, once the database is created, we would like to connect to that database. We would like to create our tables. We would like to create indexes, stored procedures, views, triggers, and so on. So for this, we will need the client side utilities. The client utilities which we have used here for probably SQL Server on premise, the same set of client utilities we can use for SQL database also. So right now I'm using SQL Server Management Studio, the most popular with SQL Server. The same SQL Server Management Studio can be used for connecting to SQL database. So we need to provide the connection string here. Now where do we get that? I go back to the server, and in server DSS SQL demo DB, demo server, here we will get the name. It's not giving the connection string name here. Okay, we have to go to the database. Let's go to the database, and here we are getting the server name, DSS SQL demo server dot database dot windows dot net. You can copy this, come back, paste here. Then we need to provide the username and password. Password whatever you gave at the time of creating the database, and you see that this is going to fail. It will not create the database. The restriction is on the IP. By default, SQL Server, the one which we created, SQL Server, does not allow any public IP to connect to it. There is a firewall setting. So we have to now go to the portal, select the SQL Server, go to the firewall settings, and here we have to add the IP, the range of IP which we want to allow. So right now I want to allow only my local IP, my client machine IP. I can check my client machine IP here. Just type IP address and Google will give you your IP address. So I can go and allow this particular IP. But instead of we doing that, you just click on add client IP. Automatically it will get that list. Same thing. Same 238, 238. From and to are same. But if you want, you can go up to 0 to 255. So in your region, if you're connecting once again, there is a good chance that only the last part would change, the other three would become same. So everybody from this region now would be able to connect. This region of the IP address would be able to connect. In locality of this IP address would be able to connect. Save this. Once I save it, I go back to Management Studio. Again, I try to connect, and this time it works. We will be able to see the database now on the left. Now once we are able to see the database, obviously we can perform any kind of query on this database. DSS demo DB. Now use it like usual. Right click, new table. But point is, You're not going to get a designer support. There is no designer support. You have to write code, you have to write queries, create, alter, drop, insert, all these things you'll have to manually do it. That means only through queries you can execute or create your database. So now what we will do is we'll go to step 2. Right now what I showed you is how to create a database and how to connect to that database from SQL Server Management Studio. This is part 1. Now in part 2 we are going to do everything locally first, including development of some application where we are making use of that database, and then we will deploy this into the production. That means our application as well as database, how to move into production. That's what we are going to see in part 2. So I'll now go to Visual Studio and try to do most of the stuff locally first. Maybe I'll create a new project and let us create a web-based application which we are going to publish it as a web app in ASP.NET MVC web app application. It can be Windows form, a web form also. Now first I'll begin with creating a database. Server name, I'll use the local Express edition which I have. To that I can connect using Windows authentication. Let's give a database name. We'll also create tables. Standard, something like employee table. ID is the primary key and identity column. EMP name, something like salary, and you can have as many columns as you like. I'll just say not null, update. Table is created. Insert data in that table, dummy data. Let's say E1. Something. And this database table, I would like to now use it in my project. So I'll write code in the controller. Let's say we'll write in the index method itself directly. So first thing to connect to the database we will need is connection string. So how do I get the connection string? For my local database, I can simply go to properties, select the database here, go to properties and copy the connection string. Just select the database, press F4 and copy the connection string. And this I'll put in my web.config. Provider is system.data.sql client. DemoDB CS is the name I have given to the connection string. So here now, using system.data.sql client, begin with creating SQL connection. To get the connection string, system.configuration.configuration manager dot connection strings of the connection string name, DemoDB CS dot connection string. So we created connection object. Then we need to create the command object which we want to execute. I want to execute a simple command, that is select star from employee with the connection. Now open the connection, execute the command. If you are not aware of programming, just execute all these things. These are not relevant to you. And here we decide whatever we want to do with that connection. So what I'll do is I'll create a modal object. I'll call it as employee. And the model object will have same properties, integer id, emp name, salary. ID name salary. So here I'll create a list of employee which is in models namespace. So here I should create an employee object with ID, name and salary. Let's write in the next line. emp.id is equal to, we should say integer dot or convert, let's use to int 32 dr of 0. emp.name is equal to dr of 1 dot to string. emp.salary is equal to convert dot to decimal dr of 012. Actually we should give column name ideally. I'm just getting lazy there. List dot add the employee, and this employee I'll pass it to the view. Not employee, sorry, list. I'll pass it to the view. So now what to do? Finally, we should generate the view. That means index.cshtml should be recreated. I'm deleting it. And I'll right click here, add view, and I'll use the template list with the model class employee so that it auto generates the skeleton of the view for me. The scaffolding template will generate it for me. Perfect. All this is automatically generated. We are not interested in edit, delete and stuff, at least for our demo. So I'll delete this. I want only 2 columns. Now run this locally. Everything should be fine. See, if you are, again, I'm repeating, if you are a non-developer, this part of the topic was not relevant to you. You should know that somebody will develop application and give it to you. So this is a application locally developed with local database. That is important. Now, how am I going to use this in Azure? I have to publish the web application. I have to also publish the database. Both the things I'll have to publish now. So first, I'll go back to Azure and I'll create a app service web app. You can actually choose app service web app plus SQL. That means you can create application as well as SQL database at the same place. But I have already got the SQL database, so I just choose web app. Just that the options in creation will be different. I mean, we'll have one extra row here where we can specify the database name. So app name, DSS demo DB, existing demo resource group. I want to create a new plan, that is fine. DSS demo plan, basic tier is good enough. Actually, shared is also good enough for demo. You don't even need to take basic. If you're running short on the cost in your free trial account, just use free shared. So this is going to create the web app, and then I'm going to publish it from here. Now, before I publish, I need to take care of moving my database first. So I'll go to the database and I'll create an SQL script for it. Right click, task, generate script. I have only one table, but maybe in production you'll have a lot of tables, a lot of other database objects. So I'll choose entire database, specify the file name, advanced, this is important, advanced, and here convert user defined data type to base type. You'll have to do that because we know that SQL database does not support user defined data types. Convert them to base type. Use database is not supported, so change this to false. Along with database schema, I want data also, so schema and data. Extended properties feature of SQL server is not supported, change this to false. I think that's it. So these are the changes we'll have to make. Click on OK, click on next. Next, we'll have the script generated. Obviously, we can copy this script. Oh, sorry. I generated script for Azure database only. I should actually connect to one more database, which is local first. I can use the other instance. I used connect. I have to redo all the steps, but that is fine. I have demo DB, generate script. Next, advanced, change this, change this, change this, change this. Rest is okay. Finish. Now once this is done, it's pretty simple. Just go here, on the database, right click, new query, and here we have to execute that query, which I have it in D colon SQL script. Of course, even now we'll have to make certain changes. Let me do that. Again, on top you see create database, all this is generated. Create, alter, all these things should be deleted. You have to delete up to the first create table. Everything should be deleted. Scroll down and last you will have alter database, delete that also. Rest keep it. Of course, here it is just one table and few inserts, but imagine a real production database. You'll have a lot of tables, lot of inserts, lot of other stuff, lot of database objects. And we know here the database selected is this, just say execute. And we have migrated our database. Pretty easy. You can actually right click here, refresh, and you have it. Or this is one way of doing it. What I did, I created a SQL script in Express and I moved, that means I've actually copied the SQL script and I pasted in the SQL text editor for this and executed the script, this database. Alternatively, I can actually go here, let's say drop table employee, or let's keep that as it is. Right click here, and here there is a direct option available, deploy database to SQL Azure. You have a direct option. New database name, in Azure you have to provide, sorry, this is the local database. First specify the name of the SQL server. Yeah, new database name, I'll keep it as DSS demo DB1. There will be one temporary backpack file created. Where should that backpack file be created? On your local machine, that you can specify here. After the operation is completed, you can delete that backpack. So actually what happens is, from your local database, it will create a backup by creating a backpack file. It will upload this backpack file and it will extract that backpack file on server. In background, all these steps will happen. So I'll connect to the remote database here. The new database connection string. Problem is this: we are not able to choose an existing database here. It will create a new one here. Click on next and finish. It will do everything for you. And on completion, you will again find that the table is. There are certain rules. The tables must have clustered index before we move into SQL Azure. Any table, if it does not have a primary key or clustered index, you cannot move that table into Azure. Very important. So it is in production not as simple as I am demonstrating. There are certain practical problems we are going to get in production. One, in production it may happen that your database is 1 GB. Now if your database is 1 GB, your machine should have enough memory to accommodate 1 GB of data in memory before it can migrate. So your RAM should be high. As I said, clustered indexes, primary keys are must for every table before we move into the database. And there are some features which probably I would have used in my local, and if they are not supported by SQL database, then also this is going to give you error. It's taking comparatively longer time because I told you in background it is first taking the local backup, it is uploading the backpack file, and then it is going to create the database on the target. Everything is happening there. Of course, the final outcome of this is you'll have a table and same data here. So you have this tool in case you want to make use of, you have good internet connection, you have all the features taken care of, use this. We are able to quickly move from here to here. Likewise, there is also something similar. I would let it you use it. SQL migration wizard. This also almost does the same thing. You have to download that tool, install it on your machine, and use that. It's a open source. Run this SQL migration wizard.exe file. And you have the choice again. Analyze only, analyze and migrate, run TSQL without analyzing, server maintenance. What do you want to do? Where is your target? My target is SQL database latest version, from one version to another version if you want to migrate. SQL database. So it's not just for SQL Azure but also for other stuff. So my requirement is migrate the database. Connect to the local first. Same story. connect to server, for which we need the connection string. Just reconfirm it. Database dot, not SQL. Sorry, I should have chosen Windows authentication here. Here also we can specify the database. All default steps, nothing complicated. I mean, network related server was not found is or is accessible. Spelling mistake. This also should change actually. Earlier, initially when SQL Azure was there, username was supposed to be actual username which we provided at the rate the server name. That was a requirement earlier. So actually we don't need this now. And it should be able to connect even without that. Database is wrong. Come on. Network related server was not found or not accessible. Verify that the instance name is correct and SQL server DSS SQL. Aha. Ideally copy and paste. That's it. Select the source. What all you want to move. Specify the options. Regenerate the SQL script. Click on next. So what I did manually using SQL Server Management Studio, it is doing all that for you step by step through code. So somebody has written a open source studio project, C# project. See, next, Connect to the server once again and execute. Do that. So this is how three options. One, in Management Studio, generate a script and do it. Two, use the direct option available here on the database. In Management Studio only, right click on the database, task, deploy database to SQL Azure. And three, use SQL migration wizard, an external tool, third party tool. I mean, not by Microsoft, but promoted by Microsoft. So whatever I have covered so far, it's all in proper sequence here in case you want to reproduce these steps. You have to first create SQL database, for which create the new SQL server and then create the database. How to use the SQL Management Studio for migrating the data. You will not be able to connect, so you'll have to give the IP to connect. Through Visual Studio, how to check your connection string. A simple example is provided. And to migrate, you can use Management Studio or this, or Microsoft SQL Server Migration Assistant. Some other tool is also there. These are the four options you have to take care of: convert UDDT, extended properties, use database, schema and data both we may want to move, and some sample code which is little different from what I did. And the connection string. Now how to move the application? We have the application, right? Which is very important. We have the application with connection string. How to migrate that? Now there are multiple options here. One is in web.config, I have the connection string. So this connection string I'll copy and I will expand this web.config, and under what I'm going to publish, let us assume that I'm going to publish a release version. So I'll go to web.release.config and here I'll provide the connection string and I'll copy these attributes. You see here some sample is given. So I'll copy the transformation attributes and I'm saying that I pasted it here. So when attributes name match, that is this name, then replace and use this connection string. That's the meaning here. Use this if the name of the attribute match. So when I publish and run the application, let's do that now. The uploaded web.config will have this connection string, that is from web.release.config. You can go to settings. See, right now nothing is there, it's fetching. Right now it will get me this. I don't want this. So I'll actually cancel this. I forgot to make the changes to this connection string. Now this is the connection string which is supposed to be of the Azure SQL database. So go to Azure now, and in Azure you have got database, and here you see connection string. Show and copy this in Notepad. Now you'll have to make some small changes. One, you'll have to change the username. Two, you'll have to provide the password. some parameters may not be required, you can delete it. I don't want to encrypt my database, so this is not required. Trust certificate, connection timeout. This is also actually not required. So copy this and paste in. I'm repeating. Here it is local database connection string, whereas here I'm going to provide the actual connection string from production. Now let's publish. And after publishing, because the database tables are already published, everything should work fine and we should be able to get the result. But what if it's not developer, but the operations guy want to provide the connection string? Right now, developer is able to do it because developer is publishing it. But what if somebody else wants to do the connection string? I don't want to go and edit web.config every time. That also I don't want to do. I don't want to do an FTP to a application, download web.config, make changes and then upload. I absolutely don't want to do that lengthy, dirty procedure. So what is the alternative to provide a connection string? We'll see that little shortly after we get the output here. We want the application to be published so that we can see the output. It's completed and we are getting the output here. Hope everything works fine. It's taking longer time. Perfect. So we are now connected to a Azure website, and Azure website is using Azure database. But then, as I said, what if the developer wants to give connection string? Yes, the solution is simple. Developer can simply edit web.release.config, provide this connection string, make the change here and give the server connection string. But what if I want to override that? So then I'll go here to the web application. And here I'll have application settings. And that application setting I'll provide here, connection string. So name should be same, DSS demo DBCS, compulsory. Like we did app settings, the same procedure here also. Then we should have this value also copied and pasted here, the connection string. So this overrides whatever is there in web.config. So tomorrow if the database has changed, you don't want to change web.config, you don't want to change code, just come to the portal and make the change here. So now the web application is going to use this connection string for connecting to the database. You don't have to change the code, you don't have to republish, you don't have to do anything, and it works as it is without any problem. That's it. So this is how a proper web application can be published into Azure. So this is one aspect, which is routine job. We are going to have a local copy of the database, a local copy of the application, both being published into SQL database. And of course, on publishing, to connect them, we either use web.release.config, override the value of connection string, or ultimately the best thing to do is in portal, go to application settings, connection string, and with same name provide the server connection string, because that overrides everything which is there in web.config. So that's all for connecting to database through an application, one part of this particular module.